The universe. Rather beautiful, isn't it? It's quite literally got everything, from the very big to the very small. Sure, there are some less than savoury elements in there, but on the whole, scholars agree that its existence is probably a good thing. Such a good thing that an entire field of scientific endeavour is devoted to its study. This is known as cosmology. Cosmologists look at what's out there in space and piece together the tale of how our universe evolved, what it's doing now, what it's going to be doing, and how it all began in the first place. It was Edwin Hubble who first noticed that our universe is expanding by noting that galaxies seem to be flying further and further apart. This implied that everything should have started with the monumental explosion of an infinitely hot, infinitely small point. This idea was jokingly referred to at the time as the Big Bang, but as the evidence piled up, the notion, and the name, actually stuck. We know that after the Big Bang, the universe cooled down to form the stars and galaxies that we see today. Cosmologists have plenty of ideas about how this happened. But we can also probe the origins of the universe by recreating the hot, dense conditions that existed at the beginning of time in the laboratory. This is done by particle physicists. Over the past century, particle physicists have been studying matter and forces at higher and higher energies. Firstly with cosmic rays, and then with particle accelerators, machines that smash together subatomic particles at great energies. The greater the energy of the accelerator, the further back in time they can effectively peak. Today, things are largely made up of atoms, but hundreds of seconds after the Big Bang, it was too hot for electrons to join atomic nuclei to make atoms. Instead, the universe consisted of a swirling sea of subatomic matter. A few seconds after the Big Bang, it was hotter still, hot enough to overpower the forces that usually hold protons and neutrons together in atomic nuclei. Further back, microseconds after the Big Bang, and the protons and neutrons were only just beginning to form from quarks, one of the fundamental building blocks of the standard model of particle physics. Further back still, and the energy was too great even for the quarks to stick together.